Hello everyone. So last week Minecraft added this new posteffect command and basically everyone's been going crazy about it. Like you can see here, they just added all these different effects, and basically how this works is they're just basically taking these effects from Shader That's like a website where you can upload your own shaders. And what this does is, like, it takes a screen pixel coordinate and then it does a bunch of math with it, and then it outputs a screen color for this coordinate. So if, for example, in the middle, that's like coordinates 0.5, 0.5, and then it does some math with that, some mathematical function, and then the function outputs like 3 different numbers that each represent the red, green, and blue channel. And like these represent different brightnesses along the blue channel in this case. And the idea is, in Minecraft you can do the exact same thing and just basically copy and paste this code into Minecraft. And well, that's what they did, and it's pretty cool because you can like insert all these different effects. And basically what I was thinking, like right here you can see these are actually 3D effects. Like right here it was just a 2D pixel coordinate, but these are like 3D, but the principle is still the same. Like you can see here, this one's also a 3D effect, and when you scroll way down, you can see it's still just a 2D pixel coordinate, and well, then it just does some geometry to basically turn this 2D pixel coordinate into like a point in 3D space and a direction that you look at, like right here, like a camera position and a vector pointing in the direction that you look at, and then it casts this ray inside the world and just basically decides which color does it hit. And this is how all of these different effects work, like this one and this one, they all look pretty nice. And basically what I was thinking, all of this stuff is just some fixed camera positions, like it works pretty well as a screensaver. Like for example, Phoenix SC also did a video about it, and all of the people in the comments are saying, well, this is basically a screensaver. And I was thinking it would be pretty nice if this was not a screensaver, but instead you could just move around this like it was a regular Minecraft world. And basically this is what I did. So you can see right here, I'm moving around inside my world, and this is exactly the effect that you see here, but inside Minecraft, and it's not just a static screen effect. You can actually move inside it, and like it gets occluded by walls and everything. You can also like go to the overworld and see how it looks, and it's pretty nice. And now you might be wondering, like I explained a bit, but how does this actually work? And the basic idea is that this ray direction, like when you look in here, inside here, all of this code is just for setting up like which position in the world is the camera at, and which direction does the current pixel, which direction in the world do you have to face to point at this pixel. It does all this different math, and then it's just inserts it into this camera setup function and calls a render function, and then it has this color and outputs it to the screen. So I was thinking if we can go inside Minecraft and do like a bunch of math that tells us which direction each pixel on the screen points to, we can basically insert it into this code, and we have this effect working inside our world. And well, you might be wondering, how does this actually work? How do you calculate this ray direction? And there are two answers to this. First, it's complicated, and two, it's actually quite simple. So this is basically my project setup, and the core of the whole idea is like all of this random code does like a bunch of matrix math to convert between screen space and world space. Like this is the core shader. Like this is what's used to draw all the things inside the world, and the game basically has internal logic. Like this leaf block is at I don't know which position like negative 116, 73, minus 90. And then this position inside the world needs to be converted into like which screen coordinate, like x and y, where does this block need to be drawn. And this is basically the logic that is done by this core shader. Like all the core shaders are used by the game to draw the things in the world, like the blocks, or in this case, like item entities in the world. And all of this conversion sounds pretty complicated, but it's actually just this one line of math. You don't even need to understand how matrix multiplication works, but it's basically just like some function that when you multiply the position by this weird object, you just get a screen position out. And this is basically the whole idea, because this is like a mathematical object, you can just call inverse on it. This is a built-in function in OpenGL, like just takes this mathematical object and gives a new one that's just when you multiply it back, it just undoes the whole operation. And then when you somehow output this into the post shader, like it's been a while since I read this, but like right here, when you output this into the post shader, here I have it output. You can just multiply it back into the screen position, and well, then you get a world position. And this is basically the whole trick. Using this, you can take any position on the screen and multiply it with this inverse matrix, and it basically gives you a direction inside the actual world. And this is then what I can enter into the ray tracing logic, and then it just works. I can plug in any shader toy code that I want. And then the next question is, this is in the core shader, and then this is the post effect shader. How do I actually transfer the data between the two? And I've been hovering over it with my mouse a bit. Here in the bottom left corner of the screen, maybe if I make the screen large, you can see it. Here in the bottom left corner, you can see some marker pixels. And actually, when you go into the core shader, you can see it like this is the vertex shader. This one's one time for every corner of the block, and then I'm outputting it into the fragment shader. This one's for every pixel of the block, and basically decides like which color should be drawn here. So like right here you can see the already existing game logic for looking up the leaves texture. And what I just added here is like if this special entity is currently being handled. In my case, I'm just using like a command to spawn a custom item display, and I'm doing a test. If this item display is currently being rendered, I'm setting this send data variable to 1, and then in the fragment shader I can test for this, and basically just run any logic I want, and in this case, I'm just testing for the pixel coordinates, and depending on the pixel coordinate, I'm encoding a different part of this matrix. And this is basically all the logic that is behind it, and that's how I'm writing these marker pixels. And then inside the post shader, I'm outputting this matrix from the vertex shader to the fragment shader. The idea behind this is basically the vertex shader only runs one time for every corner of the whole screen. So this is basically more efficient if I read it in here. And yeah, I forgot how I'm actually setting this. Alright, using a for loop. I'm just iterating over all pixels on the screen, or like just up to 4 pixels. And I'm iterating over these and reading from the screen and decoding it and writing it into the matrix. And this is basically all that is to it. It sounds pretty complicated, and I admit it is, but I hope I could make it a bit understandable how this works. But now comes the actual mind-blowing part. This is Minecraft 1.21.10. The changelog that I read at the start of this video was for 26.3, so this was like 1 year ago, and now people are freaking out about being able to render all these static images. And well, the question would be, why are they freaking out if I was able to do this 1 year ago? And well, the answer is actually pretty clear. Like, you have just these simple command blocks, and you run one command, and you do like half of what I did here in all of that. And I've also seen some other people like use these commands to send data to the post shader, and in my opinion it's pretty inefficient. Like, they used one command to send 1 bit, and right here I'm using this tiny area of the screen to send like this whole matrix. But yeah, I just wanted to show off what it actually looks like when you do this stuff. And I hope people can use my approach and do some cooler stuff with it, because like, this is a pretty cool start. Most people hadn't even noticed that you can do this shader stuff, and now that Mojang added this new command, I hope people get more into it. Like I mentioned, Phoenix SC. He already showed my Portal project, but he seemed pretty confused by it, and now he started to actually write his own code. And like, I hope people start to share my passion, because this stuff is pretty cool. So this was about everything I wanted to show. I hope it wasn't too confusing. I hope what I showed you had a bit of a point. But yeah, thanks for watching, thanks for listening to me, and goodbye.